All right, let's combine a few concepts from a couple of different chapters. Several, actually. Many. All right. What mass of zinc, we're going to do mass in grams, what mass of zinc is needed to fully react with 8.00 grams of a 6.0% by mass hydrobromic acid solution? All right. First off, like all of these stoichiometry problems, what are the units of our answer? Well, it says what mass, and I said we're going to do it in grams. So we're going to say, okay, it's grams of what? Zinc. That's what we're shooting for. Now notice there's a key word in here. What's that key word that tells you need something that's not provided? What mass of zinc is needed to fully react? React. That tells me I need a balanced equation. There's some stoichiometry action somewhere in this problem. So I'm going to go ahead and write that out. Zinc is reacting with HBr. So I'm going to say zinc plus HBr. Well, this is a redox or single replacement reaction, so the zinc's going to come in and boot out the hydrogen. Zinc is going to get oxidized. Hydrogen is going to get reduced. So we're going to make some zinc bromide. Zinc forms a +2 ion, so we know that we need 2 bromides. And hydrogen is diatomic in its elemental state, so it's H2. So that's the products, and we just need to balance that guy. So now we have our balanced equation. We're ready to hop on that stoichiometry train. Got grams of zinc. Notice it's not something per something. So we're not going to start with something per something. Well, what do we have? Well, we have 8 grams. That's not something per something. And we have 6.0% HBr. Remember, this is by mass. But remember, this thing here can be expressed as 6.0 grams of HBr. Remember, there's 2 parts to every solution. There's the solute and the solvent. Well, in this case, the solute is HBr. Okay. The solvent is water. It doesn't say that, but it is. So remember, it's the mass of solute divided by, or this number in grams or mass units, divided by 100 grams of solution, the whole thing. Remember, solvent and solute come together and they make the solution. Alright, so this is actually a conversion factor, something per something here. 6 grams of HBr per 100 grams of solution. So I'm not going to start with that. Here my grams are still hanging out here, my target units. So I'm going to go ahead and start something that's not something per something. And I'm going to start with 8.00 grams of solution. Okay. HBr solution. Now I need to get from HBr solution to eventually to zinc. So I know I'm going to have a mole to mole ratio in here somewhere. Okay. So I'm going to go ahead and get this into moles. Well, how am I going to do that? Well, I can use this conversion. I can say, okay, I need grams of solution, SOL apostrophe N. It's an abbreviation for solution. Grams of solution down here. 100 grams because that's what's going to cancel. 6.0 grams of HBr. Okay. And for my periodic table here, somewhere in here, well, I have a green one. I'll use the green one instead of the orange one. So if I stop now, grams of solution, I have grams of HBr. I need to get this into moles of HBr so that I can use my mole to mole ratio. So remember, H has a molar mass of 1.01079, so 1.01, and bromine over here has a molar mass of 79.9. Okay. So bromine is 79.9. So what do we have? We have 80.91 grams per mole. So I know that I need grams of HBr down here. 80.91 is 1 mole of HBr. Now I can get from HBr to zinc, and I can say, oh, okay, for every 2 moles of HBr, I react with 1 mole of zinc. 2 moles HBr gives me 1 mole of zinc, or reacts with. And now, if I were to stop right now, grams of HBr, moles of HBr, I'm left with moles of zinc. So my last conversion, we have to go from moles of zinc to grams of zinc. Well, where can I find that? Molar mass on the periodic table. And here we are with zinc. What is that? 65.39 grams per mole. So I know that 1 mole of zinc is 65.39 grams of zinc. Moles of zinc cancel. It's kind of hard to read, but that's 65.39. So now I'm going to go ahead and plug and chug. 8.00 times 6. I'm not going to worry about the 2 ones. Times 65.39 times 65.39 divided by 100 divided by 80.91 divided by 2 equals 0.19. Well, how many sig figs are we good to? 2. And that's 193, so just 19 grams of zinc. Now, I want to just double check my calculation because I may have hit a goofy button. 8 times 6 times 65.39 divided by 100 divided by 80.91 divided by 2 equals 0.19. Okay, bingo. Little nomenclature, little balancing of chemical reactions, completing chemical reactions, did some solution percent concentration, and finished it off with a batch of stoichiometry.